Hello everyone! This video contains the exercises for the previous lesson in which we discussed functions as brushes. So we are going to dip into a bunch of things, from pulsing, repeating patterns and pixelation, to CRT scanlines, flags, and even fire animations for our rocket ship. So before we get started, I have created for you a base shader that you can use in order to more easily solve the exercises. But what this shader does is to simply get the UV with the flipped Y coordinate, and also if you have the uniform ball show UV enabled, to actually show this UV. However, on top of that, I also have these uniform floats for H, HS, V, and VS, which are just variables that you might want to use if you want to experiment more with your own functions. Finally, there is a threshold variable that again you can use if you want to actually draw the functions to make completely sure that you got the answer right. Okay, but with that in mind, let's get started with the first exercise about pulsing. What I want is to make this sprite pulse to be fully visible and then to be fully invisible, and then again fully visible and then again fully invisible. So think of a function that has this oscillating nature and think of the property that you have to modify in order to make this visible or invisible. Give it a shot and let's see the solution. Alright, now the first thing to consider is the fact that we want to make this transparent. Now, to do that, we obviously have to change the alpha value of this, which is a float. So what we need actually is just a float value that will change from 0 to 1 and back to 0 and back to 1, right? So let's just make for now a float pulse and make it 1.0. And if we want to modify the transparency, we just have to multiply it by the pulse. So what I'm going to do is to just say color.alpha multiplies with the pulse. And right now nothing happens because it's always multiplied by 1. Okay, but what function can we use that oscillates? Well, we could use a sine function. So I could use a sine, and as a parameter, because I want it to continuously oscillate, I could use time. And if I now save, you see that my sprite went invisible, and then is visible again, and then went invisible. But as you might have noticed, it's invisible for quite a long time. And why is that? If you take a look at it in Desmos, you will see that the sine function is below 0 for quite a long time. Now, to fix that, what we have to do is to somehow find a way to bring up this sine function so that it only ranges between 0 and 1. And how can we do that? Well, of course, we could use the generic formula that I've shown you in the previous video, but it's quite obvious that if we reduced this function to half of it, because it ranges to between -1 and 1, so if we multiply this by 0.5, we would get a much smaller function. So the only thing that remains to be done now would be to shift this function up in order to make it so that it ranges between 0 and 1. And to shift it up, we have to subtract from y 0.5. Okay, now if we want to set all this result inside the float, we will have to move this -0.5 from the left side to the right side, so plus 0.5, so that all these values can be assigned to a variable. Okay, but if I go back to Godot, if I multiply now this sine of time by 0.5 and then I add another 0.5, you will see that the animation immediately as it gets to 100% goes down again to 0% and then immediately goes to 100%, so I'm having this pulsing effect exactly as I wanted it. Okay, now for the second exercise, what I want you to do is to repeat this texture 3 times horizontally and 4 times vertically. Think of a function that you could use in order to repeat some values, and pause the video and then let's see the solution. So a function that keeps repeating is the fract function. Now you don't have the fract function in Desmos because the representation of it is very simple. You simply subtract from the number the floor of that number. So for example, if you had 5.5, you simply subtract 5 and you get the fractional part, which is 0.5. However, if you really want to see the fract function and not this formula, you could go to GraphToy, which actually has the fract of x, and it's basically the same thing. Alright, but how can we use the repeating nature of this fract function in order to have multiple things drawn in this 0, 1 region? Well, what's nice to observe is the fact that whatever value this function gets, the result is always going to be between 0 and 1. And yeah, of course, for the interval 0, 1, we only get a singular result. But it would be nice if we could squeeze somehow the result of our function so that in the 0, 1 interval, we'd get more than a single line going between 0, 1. So, do you know any way in which we could squeeze a function? Well, of course, we could add the horizontal scaling parameter, and we do that by dividing x by some variable that we create. So we divide x by age underscore s, and here we divide x by age underscore s as well to be consistent. And if I now add this slider, you will see that increasing and decreasing the slider squishes and enlarges my function. Now, in this case, a small problem that I have is that I cannot quite exactly get 3 of these lines in my 0, 1 interval, and I might have to guess to have something like 3.5, 3.4, 3.3, and to be something like, okay, this is fine. But if you have this situation in which you don't have enough precision in this 0, 1 interval, what you could do would be to change the direction in which the scaling happens. And what do I mean by that? Well, you can see that now when I increase the scale basically increases here on the graph as well. And when I decrease the scale decreases, or the thing gets more compact. But you can invert that if you want. So for example, if I want to make this thing smaller the more I increase this, what I have to do is to change from division to multiplication. So I could do x multiplied by age underscore s. And here I could do the same thing, multiplied by age underscore s. And now the more I increase it, you see that the more elements I get inside this 0, 1 interval. So now if I increase it to the value 3, you see that I had a bit more precision and it was easier for me to find the correct answer. So we can now go back to Godot and apply what we did in Desmos so that we get a repeating pattern horizontally. And because we want it horizontally, what I'm going to do is to modify uv.x. And how do I modify it? Well, I'm just going to apply the function that I defined previously. So uv.x is going to be equal to uv.x multiplied by 3 minus the floor of uv.x multiplied by 3. And as you can see, my UVs changed into this repeating pattern. But if you remember, this trick of x minus floor of x was used just because Desmos doesn't have the fract function. So what I can do actually is to replace everything that I have here with fract of uv.x multiplied by 3 point. And as you can see, I got this value back. Okay, but you might have noticed that if I want to split this in 3, what I have to do is basically to just make fract of uv.x multiplied by 3. So if I said that on the vertical axis I want to split it in 4, what I can do is to say uv.y equals to fract of what? uv.y multiplied by 4. And as you can see, I have now split it in this 3 by 4 matrix. But even more than that, I don't have to do this separately. I could do it into a single move. So what I could do would be to have, let's say, a vector2 called grid size and make it vec2 of 3 point and 4 point. And then I could just get the fract of this grid size for my UVs. So what I could do would be to say UV equals to fract of UV multiplied by grid size. And as you can see, I'm getting the same result as before. Now, it doesn't really matter whichever version you prefer. What matters is that we want to also sample the texture to represent what we have here. And to sample the texture, just as usual, what we are going to do is to say color equals to texture of texture and comma UV. Now, what you might notice is that everything here is upside down. And why is this happening? This happens because in Godot, the y-coordinate still grows while going down. So what we need to do is to specify when sampling the correct direction for the y-coordinate. So not the direction that we used for visualizing functions. So we have two options. We could simply modify this back to uv.y because we're not visualizing anything anymore. Or we could here again construct a different vector. We could say something like vec2 of uv.x and 1 point minus uv.y. And by doing this, we basically allow ourselves to visualize functions with this reversed uv.y, but we sample correctly the color of our texture by using the correct reversed uv.y. Okay, now for the next exercise, given a pixelation factor, we want to pixelate this texture. Think of a function that you could use in order to basically remove some of the information in the image so that we can have the image pixelated. Before pausing, what I want to mention is that you shouldn't get discouraged if you don't get this in the first try. You generally get the gist of how to work with certain functions only after you have seen them in practice at least once. So if you don't really know the solution right away, you will know for sure what to do after you see the solution resolved here. So anyway, pause the video, give it a shot, and let's see the solution. Alright, the function that we're going to use is going to be the floor function. But why is that? Well, because if you take a look at the interval between 1 and 2, for example, what happens is that the floor function always gives the result 1. But our normal function, our identity function, would give the result in the whole interval, so 1.1, 1.2, and so on, until it reaches the point 2. So, as you can see, the floor function kind of loses some of this information. Okay, but how does that help us? Well, if we look at our UV interval, which ranges between 0 and 1, currently, if we were to just use the floor function, we would get 0, so we would get an image that's perfectly black. But what we can do is to multiply this square so that it reaches whatever size we desire. Let's say it reaches the size of 20 by 20, and now whatever values we had in there are going to be discretely split into these exact values that are returned by my floor function. And afterwards, after transforming the image into an image that's basically lower resolution, in order to see it back how it was, we just have to scale it back down from 2020 to 0.1. Okay, so making the effect back in Godot is going to be pretty simple, because we just have to follow the steps that we previously mentioned. So we want to set our new color to be, of course, the color of the texture, so I'm going to sample of texture and the actual UVs that are going to be pixelated. So let's call it pixelated UV. Okay, now let's define these pixelated UVs. So vec2 pixelated UV and make it equal to what? Well, first of all, we said that we want to enlarge our UVs so that they reach a range that we are comfortable with. So for example, we want our UVs to take the value of pixelation factor. So let's just say pixelated UV equals to UV multiplied by pixelation factor. Okay, but even now, despite not seeing anything here, if I change the pixelation factor, you'll see that by 1, nothing happens. But if I change it to 2 or 3 or 4 or so on, the UVs basically cover a larger region, and that's why my image here looks smaller. So it means that whatever we did here was correct. Okay, now the next step would be to reduce the resolution of this whole thing. And to do that, again, I said that we are going to use the floor function. And if I use the floor function now, you really are not going to see anything anymore. And you're not seeing anything because floor only returns integer values, so returns 0 and 1 and 2 and so on, and the UVs represent values between 0 and 1. So what we have to finally do is to take back our UV into that region with these new calculated values. So what I'm going to do is to divide again by this pixelation factor that we multiplied with. And as you can see, I'm getting maybe a slightly too pixelated thing, but if I increase or reduce this pixelation factor, I am getting a pretty nice pixelation animation effect. Now, as you might notice, I have a slight problem, which is the fact that these values are outside and I cannot see them, but this happens because of the nature of floor, which basically gets the immediate integer that's below the value that I'm providing. So to also get that value, I'm simply going to add here +1 to my pixelation factor, so +1. And as you can see, I am now getting the full texture, which is from very high resolution to very pixelated. Alright, for the next exercise, I want to create a CRT effect. think of a function that you could use to generate a bunch of lines that climb gradually to the top of this Godot icon. Pause the video, give it a shot, and let's see the solution. So first of all, I have specified that I want these CRT lines to add color on top of the already existing color. So to do that, obviously I'm going to have my color, the initial color, to which I add some other value. Now I do not really want to touch the alpha, I want to keep the transparency as it is, so what I'm going to do is to simply write color.rgb plus equals, because I want to add what? Well, some other vector 3 that is defined by my CRT value that I'm going to calculate. Okay, but how do I calculate this CRT value? Well, this CRT value is going to be a float and it's going to be equal to a repeating function. The function that I will choose is going to be the sine function because it's pretty simple to use. And I'm going to use that sine function on uv.y as I want the lines to climb up vertically. So I'm just gonna write sine of uv.y. Now, if you take a look at it, obviously I basically only have one line. So to resolve this problem, what I'm going to do is to simply multiply this uv.y by, I don't know, 20. Okay, maybe this is not enough, maybe 200 would be good. Yeah, this looks much better. It looks something similar to what you'd see on a CRT TV. Alright, but a problem that we have is definitely that these lines are way too intense and some of the values have turned to black, so why does that happen? And also that the lines are not climbing up. So let's go to Desmos to see our sine function. Alright, now for the sine function I actually just multiplied by 20 because it's much easier to read if we multiply by 20 here. And you see that the main problem is that we have this sine reaching the values of 1. And if we add 1 to any kind of color, what's going to happen is that the final color is going to definitely be white because 1 plus anything is going to give some value that's either 1 or larger than 1. So what we have to do is to make this sine wave a bit smaller. And how would we do that? Well, of course, we would have to scale it vertically by dividing here by some vs value. And you see that I can make this much smaller. Now, of course, I can take this vs value and move it to the other side. So just multiply by vs instead, and the same thing is happening. And if we keep the vs to 0.1, I think it looks pretty fine, but we still have a small issue. The issue is that our sine function still has values that are below 0. So when we add this function to something else, we might actually subtract instead of adding, which would darken the image instead of just making it brighter. So the other thing that we have to do is to also move this function up vertically. So in order to move it, again, we would have to subtract from y a v value, which we can add as a slider. And as you can see, if I make this v value also be 0, 1, I am getting a sine function that's always above 0. And of course, again, I can move this minus v to be here, so plus v, and I get the function that I want. So basically, my final function is going to be sine of x multiplied by 20 multiplied by 0.1 plus 0.1. And it's basically the same function, but with no parameters because we don't want to configure it too much. So now if I go back to Godot, what I have to do is to write sine of uv.y multiplied by 200 and then multiplied by 0.1 and then add to it 0.1. If you take a look at it, the color of Godot stays the same wherever this sinus reaches the value of 0, but it gets amplified wherever there is a value that's larger than 0, so wherever we have a line. Alright, but now how do we actually move these lines? Well, you might have noticed that in Desmos we had our function go from left to right or from right to left. However, in this case, we have the lines being laid out vertically. So what's the difference? Well, the simple difference is that we just used uv.y in order to represent these lines. If we were to use uv.x, you'd see that we'd have vertical lines. So the function, despite being horizontal, can still be used to represent vertical things if instead of using x, we are using y. So I'm simply going to use y again. And what I want to do is to make this sine function move from left to right, or from bottom to top, depending on what orientation we decided on. But to do that, again, we simply have to just subtract the value from x. Now, the value that I'm subtracting, I don't want it to be multiplied by 20, so I'm just going to subtract after the multiplication. So I'm just going to subtract this h value. And as you can see, this h value can be used in order to move this from left to right. So back in Godot, what I need to do, because these lines should move continuously, would be to subtract time. And if I subtract time, if I zoom in, you'll see that these move slowly. And maybe I could subtract time multiplied by 2 to make them move faster, maybe even multiplied by 4. And you can actually notice these lines going up in my CRT effect. Alright, now what I want you to do is to improve upon this CRT effect by adding another function that's a bit different from this one to give a more varied feeling to our effect. So give it a shot and let's see the solution. Now, the solution for this is pretty easy actually, because all I have to do is to simply duplicate this CRT effect, maybe call it CRT2, and add it to my already created sum here, so vec3 of CRT2. And as you can see, the effect is already amplified, but I do not want to just amplify the lines. If I wanted that, I would have just changed the values here. What I want is to have different lines on top of these other lines. So first of all, a thing that I could do would be to maybe reduce the speed of this effect. So make it time multiplied by 2. And what I could do maybe would be to make the lines thicker for this effect. So I could make it like, I don't know, 60 here. And as you can see, I'm already getting this effect, maybe even thicker. Let's try 30 or 20. Yeah, something like that. It looks much closer to what a real CRT effect would look like. Alright, now what I want you to do is to create a flag that oscillates up and down just as if it were blown by the wind. Also, what I want you to do is to think of a way to make it possible to hold one side of the flag in place while only the other side oscillates. Okay, and just before you get started, let me just show you how to make a flag of your own in case you want. So you can just go to Texture and Gradient Texture 2D, and in here, after clicking on the actual gradient and maybe moving it so that it updates, you can go to Interpolation and select Constant. If you select this interpolation, you can then just pick any kind of color you want. So I could pick red, and then I could pick yellow, and then I could pick something like blue to make the Chad flag, I guess. And with this flag, maybe if I aligned it correctly, I can now make my animation. So pause the video, give it a shot, and let's see the solution. So to simulate this oscillation, what I would have to do would be to basically increase the y values and then decrease them and increase them again and decrease them again, depending on how far I am on the flag's length. So how could I do that? Well, if I want to increase some values, of course I need to add something, right? So what I would do would be to make uv.y, because I want to increase vertically, plus equals to something. Well, to what could it equal if not to an oscillation that happens horizontally based on uv.x? So I'm going to add to this sine of uv.x. Now, of course, the classic problem is that I do not have the perfect sine function, but the point is that I managed to make some parts of the flag go lower than some other parts. And maybe to better see this flag, it would be nice to scale it a bit down so that it doesn't get clipped so easily. Now, how could we scale the flag down from a given point? So I don't want to scale it from the top left corner, I want to scale it from this point. If you remember from the previous exercises, if I want to scale from any given point, what I have to do is to take that point and put it at the coordinate 0, 0, so that when I scale, the point stays in place. So this point is at the coordinate uv.x equals 0 and uv.y equals 0, 5. So what I need to do is to subtract from that uv.y 0.5. So I would do something like uv.y minus equals to 0.5. Then I could do the scaling. So I could say something like uv.y multiply equal to 1.3 why not? And then I could just move this point back to its initial position by using plus equals to 0.5. And now my flag is slightly smaller, but the issue again is that this sign is too large. Alright, now let's subtract time in order to experiment a little to see live the changes that we are going to make. And as you can see, the oscillation is quite large, so maybe we could multiply this by 0.1 to make the oscillation smaller, and maybe we want to have more oscillations, so what I could also do would be to multiply this uv.x by, I don't know, 5, and yeah, as you can see, I'm getting quite a nice effect. And if you got here, congratulations, this is absolutely amazing. Okay, but what if I wanted to make this flag hold, to make it stay here? What kind of function could I use that whenever it's close to 0, the result is also 0? Well, if you remember these two functions, sine of x and x multiplied by 0.1, what we could do to these functions would be to multiply them together, so to have sine of x multiplied by x multiplied by 0.1. And if you zoom out a little, what you'll see is that we get this function that oscillates the further it gets from the center, but at the center it does not oscillate. So this means that at the coordinate 0 on the x-axis of our flag is simply not going to oscillate. So instead of the sine function, let's actually try to use sine of x multiplied by 0.1 multiplied by x. We already pretty much have everything we need, but we simply don't multiply by x. So if I now multiply by uv.x, you'll see that this left side sticks and it doesn't move, and only the things on the right start moving. And if I maybe wanted to make this more apparent, I could multiply this by 5. As you can see, there's more oscillations moving the flag even more, while keeping this side definitely in place here in the middle. Alright, now for the final exercise, what I want from you is to help Godot's ship fly correctly by making the fire follow naturally whenever the ship turns. Now, you don't have to do all the logic behind that. All I need you to do is to create a shader that changes how the fire orients itself whenever some parameter is being changed, for example, this t value. So think of a function that goes something like this, something like a curve, a parabola maybe, and see if you could apply that function in order to change the orientation of the flame. Pause the video, give it a shot, and let's see the solution. Alright, so a curved function or a function that looks like a parabola is actually a parabola, so you can literally just use this in order to create the incline needed for the flame. Now, what do I mean by the incline? Well, as you can see, this curve goes a bit up towards this one, and if I were to multiply this by some value, so have t multiplied by x squared, you'd see that this curve changes into the opposite direction when t starts being negative. Now, of course, because my flame was vertical, I would like to use the formula vertically, and this time let's actually try to simply change the order of the parameters. So let's just say that instead of y, I have x equals to t multiplied by y squared. And now, if you look at it, I have a curve that points towards the right or a curve that points towards the left. So let's just take this formula and let's see how it would be applied in our case. Alright, so to make our formula from Desmos work correctly, what we have to do is to, again, make the y-coordinate grow upwards. So in order to do that, I'm just going to write 1 minus this uv.y. Now, of course, I want the sprite to still stay in the same place. So here, when I sample the texture, I'm going to do a vector 2 of uv.x, and I'm going to reverse the reverse that I did before. So I'm just going to write again 1 minus uv.y. This time uv with lowercase because I'm subtracting 1 from this modified uv. Okay, but in between we have this modified uv to which we can apply our changes. And what did we say? Well, we said that from the uv.x we want to subtract, what do we want? T multiplied by uv.y at the power of 2. So I'm just going to write t multiplied by pole of uv.y and 2. And with that subtracted, I can already move T left and right, and you'll see that this flame is simply moving. And from any kind of script, so whenever your ship turns left, you would just update this shader parameter to do some interpolation between these values and to get this neat animation. Alright, now these have been all the exercises. And if you reach this point, I am honestly so proud of you because, to be fair, these exercises were not that easy. We had many things to think about whenever we tried to solve any of them. So really congratulations for reaching this point. Thanks a lot for watching, thanks to my supporters, and see you in the next one. Bye bye!